Heaters date back 1.5 million years, with the earliest form being campfires. Ancient Romans were noted to have used central heating system, in which hot air from furnaces would blow into pipes, and those pipes were underneath the floors and inside the walls. December 23, 1919, Alice H. Parker patented her natural gas furnace design. A key feature of Parker's design was zone control heating, in which multiple gas burners, baffle plates, and regulating valves were utilized to control heating in individual areas of the home. And although Parker's design was never actually used in a home, her idea laid the groundwork for modern HVAC systems.
The first aspect in an HVAC system is heating. The heating system is sent to utilize a furnace or a heat pump. With the heat pumps in heating mode, it extracts the heat from the outside air and transfers it indoors. In cooling mode, it reverses that and extracts the cold air from outside and transfers that indoors. This dual functionality in modern HVAC systems make the heat pumps energy efficient and eco-friendly when in comparison to furnaces, since furnaces generate heat through combustion of fuel, or they utilize electric resistant coils. Now, ventilation. This aspect brings fresh air from outdoors indoors while expelling stale indoor air along with other pollutants and odors. This process helps to regulate the humidity levels and also prevents the buildup of harmful contaminants that are indoors. HVAC systems tend to be equipped with air filtration and purification technologies to ensure that the air being breathed is clean.
Now for clarity, a refrigerant is a chemical compound used in HVAC system to absorb and to release heat.
The AC goes through a refrigeration cycle that removes the heat from the indoor air, providing a cooling effect. The first step of this cycle is evaporation. A refrigerant enters an evaporator coil as a low-pressure cold liquid, and as the warm air passes over that coil, the refrigerant absorbs the heat, causing it to evaporate and transform into a gas. The process then cools the air that will circulate through the home. Next, compression. The now gaseous refrigerant travels to the compressor, where it's compressed into a high-pressure gas. This stage then increases the temperature of the refrigerant significantly and prepares it for the next phase, which is condensation. Here, the high-pressure hot gas moves to the condenser coil, usually located outside the home. Then, it releases the heat it absorbed from the indoor air into the outdoor environment. And as it loses its heat, the refrigerant condenses back into its liquid state, finally going into the expansion step. The refrigerant being back to its liquid state passes through either an expansion valve or metering device, where it experiences a drop in pressure. This reduction of pressure causes the refrigerant to cool down significantly, allowing it to return to its low-pressure liquid state and thus completing the refrigeration cycle.
HVAC systems are equipped with controllers, such as these, which adjust and set the humidity and temperature. Some controllers can be set to customized schedules, which helps to reduce the impact on the environment and minimize the cost of using the HVAC system. So the next time that you adjust the temperature in your home, you know who to thank for your central heating system.